Hi everyone, in this video we look at representing sequences recursively. So first off, in a recursive formula, each term is defined in terms of the preceding term or terms. So what that means is that I can write the nth term in terms of its previous term or its preceding terms, or sometimes we have it defined in terms of the preceding two terms or the preceding or the three preceding terms. So a sequence can only be represented recursively if each term can be written in terms of the preceding term or the preceding terms. So let's look at a couple of recursive formulas. So here we've got that t sub n, the nth term, is equal to the t sub n minus 1, which is the term before, squared minus 2. Now, it's really important here that we have to be given one of the terms. So here we're given the first term, which is 3. So we know that if we do t sub 2, well, t sub 2 is going to be equivalent to the term before, which is t sub 2 minus 1, so that's t sub 1, squared minus 2. So we'll have that t sub 2 is equal to 3 squared minus 2, which is equal to 7. T sub 3 is going to be equivalent to t sub 2 squared minus 2. And t sub 2 is 7, so we'll have 7 squared minus 2, which is equal to 49. 49 minus 2, which is 47. So therefore, the first three terms are 3, 7, and 49. And 47. And 47. Okay. So, and if I wanted to have calculated the fourth term, I would have had to square 47 and then subtract 2. So you can see that I have to know the next term, I have to know the preceding term. Or to know any term, I have to know the preceding term. So that's why we have to be given at least one of the terms. In the next one, we've got that t sub n plus 1 is equal to 3 times t sub n plus the term number n. So let's see here. So here we have that t sub, let's do 1 plus 1, which is equal to 3 times t sub 1 plus 1 is going to give us t sub 2. So here, notice that the indices or the terms are the term numbers are a little bit different. Here I've got t sub n is equal to t sub n minus 1 squared minus 2. And here I've got t sub n plus 1 is equal to 3 times t sub n plus n. So that's something that's really important to note, the difference between these two formulas. Here I don't have, I have the next term defined in terms of the current term number, whereas here I've got the current term number defined in terms of the preceding term number. So one of the ways that I could make a change in the term numbers here, but I can just do the calculations based on the term numbers that I've been given. So I've got, if I plug 1 in for n, I've got t sub 1 plus 1, which is t sub 2, is equal to 3 times t sub 1 plus 1, because n, it's kind of like using function notation. You're just inputting a number for n. So I'll have t sub 2 is going to be 3 times t sub 1, which is 5, plus 1, which is equal to 16. So I've got t sub 2 is equal to 16. And then t sub 3 well, let's see, what value of n did I put into my equation? Well, now I know what t sub 2 is, so I can do t sub 2 plus 1 is going to be equal to 3 times t sub 2 plus 2. So I've got t sub 3 is equal to 3 times 16 plus 2. So 3 times 16, well, 2 times 16 is 32 plus 16 is 48 plus 2 is 50. So t sub 3 is equal to 50. So the first three terms are the first three terms are 5, 16, and 50. Those are the first three terms. If we're given a sequence, one of the things that we could be asked to do is come up with a recursive formula. Here it's useful for seeing how each term is defined in terms of the previous term. So here I've got a problem where we're told determine a recursive formula for each sequence. And for A, we've got -5, 10, -20, 40, comma, ... So let's think about this. What's happening between each of these terms? Well, to get the second term, I'm going to multiply. It seems like I'm multiplying the first term by -2. And then to get -20 from the second term, I'm multiplying the second term by -2, and then I'm multiplying by -2. So it seems like the t sub n is just the term before multiplied by -2. So let's write that out. So we've got our recursive formula. It's just going to be t sub n is equal to the term before. Now the term before t sub n is just going to be t sub n minus 1. And we're just going to multiply that by -2. And here I have to be given one of the terms in the sequence, and generally you give the first term. So where t sub 1 is equal to -5. Okay, so this is a recursive formula for the sequence. In the next sequence, let's see, we've got something that's a little bit more difficult. We've got -5, 7, -9, 11, -13. Well, let's see what's happening here. Okay, so it seems like each term is the magnitude of the previous term increased by 2. Okay, so let's say that that t sub n is equal to the magnitude of the last term. So we've got the magnitude of t sub n minus 1 plus 2. So now this would be, well, let's see what would happen here. So what that would mean is that the previous term would be, let's see, okay, so we've got -5. If we take the magnitude of that, we get 5. And then if we add 2, we get 7, which is correct. If we take 7, we take the magnitude of that, and we add 2, we get 9. If we take the magnitude of -9, we add 2, we get 11. So here we've got the magnitudes are correct. Now we just have to deal with the signs of each term. So the best way to do that is just to, let's see here, we can multiply, and let's see what, we can multiply this by -1 to the power of n minus 1. Where here we've got that if n is going to be odd, then we'll multiply by -1 to the power of an even number, which is positive. And if, oh wait, hang on a second, that's not right. If n is if the term number is odd, we want it to be negative. So we're just going to raise it to the -1 to the power of n. And now we can see that if the term number is even, we'll have a positive number. If the term number is odd, we'll have a negative number. So let's double check that this works. So, and here I've got to also write out what my first term is. So I've got that t sub 1 is equal to -5. So let's double check that this works. So I've got that t sub 2 would be equal to the absolute value of t sub 1 plus 2 times -1 to the power of 2. So this would be the magnitude of t sub 1 is 5. So I've got 5 plus 2. Oh, whoops, 5 plus, not 7. 5 plus 2 times -1 squared, which is equal to 7. So that works out, that's correct. Next I would have t sub 3. T sub 3 is going to be equal to the absolute value of t sub 2 plus 2 times -1 to the power of 3, which is equal to, let's see here, t sub 2 is 7. So I've got 7 plus 2 times -1 to the power of 3. -1 to the power of 3 is -1, and I'll have -1 times 9, which is -9. So it seems like this recursive formula holds, and it does, because here we're just going to add, we're adding 2 to the magnitude of the previous term, and if the term is odd, we're going to multiply it by -1. If the term is even, or if the term number is even, we're going to multiply it by +1, which gives us the correct sequence.